I'm going to go ahead and get started. Hopefully a few more people drift in as we go, but if not, that's okay. My name is Scott Carlson with MTH. Um, I've been here for a little over 25 years. I do all the marketing for the company, so I'll be hosting most of this webinar today. I have Bob Weller and Jim Shackman with us, both regional managers for MTH. So without further ado, we'll get going. Start off with a little bit about MTH if you're not familiar. We were founded in 1965, started by Dave Tremaine. Dave is in his 90s and still coming in all the time, still working, even though he's retired, and still very active with the company. But in the late 90s, his son, Tim Tremaine, took over as the president. And so he is currently very active with the day-to-day business. And right now we have about 80 employees. It's always fluctuating, give or take 5, but we are constantly growing. MTH owns approximately 6 square blocks of the city of Plano, Illinois. And within those 6 square blocks, we do everything here at the factory. We do all the machining. We even own a foundry next door to us that does a lot of our bronze castings for us. Dave Tremaine, after he retired from MTH, started his own motor company, DLT Electric. So we try and do as much as we can within the confines of these walls. We did become ISO certified in 2012, and we actually became ISO 14,000 in 2022, which adds environmental sustainability. So we're pretty proud of that. A little bit of a quick picture tour of our facility. One thing I want to point out is that we do have a full sales office. So when you call MTH, you get live people. You don't get a recording. So we have several salespeople working full time to answer any questions you may have. Some of the other things to highlight here, we do have our own R&D facility for our engineers, and like I had mentioned earlier, we have a lot of CNC machinery that is working 24 hours a day, 7 days a week. We do have a full tool room and pattern shop. We have a room dedicated to OEM products that will actually hermetically seal by welding pumps robotically. We have a warehouse that has millions of dollars of inventory in it at all times. The reason I bring that up is because we have an expedite program that if you need a pump because you have a customer that's down, we can do an expedite where basically if we get the order in the morning, our time, we can usually have it out that same day as long as the parts are in stock. And if it's a really big emergency, a lot of times if we don't have something in stock, we can usually figure out how to go up a size, down a size, different configuration, different material to be able to still get you your rush. So if you ever come across that, we are able to do that. Every single pump that MTH builds here in our facility gets tested. We have test stands made for all of our pumps. And then we do have a pretty large shipping area, so we can ship a lot of pumps if you have any OEMs that you need large amounts. Some of the associations and trade shows that we participate in, like I had mentioned earlier, we achieved our ISO 14,000 certification in 2022. We have been ISO 9,000 since 2015. And these are some of the shows that we participate in, and these are some of our associations that we work with. In-house capabilities. We have a full engineering department with all of the bells and whistles to be able to produce prototype pumps, as well as any kind of experimental things that your customers may have. We can do a lot of custom work. We have all the 3D modeling capabilities and everything you would need. I had mentioned earlier that we have our own foundry next door. Our foundry is one of a handful of them that is capable of doing what's called small run investment cast stainless steel. Normally, when you get investment cast stainless steel, you have to have a minimum order of usually a few hundred or more. We have a special setup in our foundry to be able to do as little as just 1 or 2 pieces at a time. This is a real advantage for MTH because we can always get castings when we need them, but we can also entertain outside work as well. So getting into some of the regenerative turbine pumps, one of the biggest characteristics about a regenerative turbine pump is that it has a steep head capacity. That means that we can achieve high pressures at moderately low to medium flows from this group of standard products here. We start out basically at the smallest and work our way up to the largest. And we do have some centrifugal pumps as well. But our highest pressure pump here is our M series. It can hit 2,300 feet, which is 1,000 psi. Our largest pumps have a run out of right around 160. That's some of our flex coupled pumps, and we do have some very specialized high pressure smaller pumps that can go anywhere from a half a gallon a minute on up. One of the things about regenerative turbine pumps, if you're not familiar, is that when you look at a regenerative turbine pump curve, here we have a 4-stage curve. There's 4 impellers to this. Each time you add an impeller, you add pressure, very similar to how a centrifugal works. Where it gets different is that with a centrifugal, the horsepower, as you increase the flow, the horsepower goes up. With a regenerative turbine pump, it's exactly the opposite. As you increase pressure, the horsepower goes up. So if this were a centrifugal pump curve, the horsepower would look more like this. But because it's a regenerative turbine pump, the horsepower looks like this because the higher the pressure, the higher the horsepower required. Compared to a centrifugal pump, so here the smallest horsepower is at the lowest GPM. As you increase the GPM, it gets all the way up to, or it gets higher. That's just to show the difference. Some of the other characteristics of a regenerative turbine pump, besides that high pressure, are that they're usually a compact design. Most of our pumps are close coupled with just a single impeller. We do have some flex coupled that get higher pressures, but because they only have a single impeller, they usually only have a couple of major components, usually casing, motor bracket, impeller, and then all the hardware that goes with that. Regenerative turbine pumps are pulsation free. If you're familiar with a diaphragm pump or gear pumps or any other pumps that are higher pressure, usually there's pulsation involved with that. With regen turbine pumps, because the impeller is constantly turning and there's no breaks in the water, it's a smooth flow. Because all of the work is being done on the outside of the impeller, regenerative turbine pumps often have really good NPSH characteristics, which I'll show in just a minute here. And because they have good NPSH, there's little to no cavitation on a lot of, on most of our products. So a little bit about how regenerative turbine pumps work. With a normal centrifugal pump, the fluid would normally be introduced at the eye of the impeller. So it would go in to the eye of the impeller. It would cross the vanes of the impeller, and then it would go directly out. So any given particle of water or any other fluid is touched by a vane one time before it is exited out the pump. If you want higher pressure with this type of pump, you can already achieve pretty high flows, but if you want higher pressure, you have to add multiple stages in front of this so that it builds up a little bit of pressure. It goes in, it goes out, goes back in, goes out to build up that pressure. Instead of doing these multiple stages like you would do with a regenerative turbine or with a centrifugal pump, a regenerative turbine pump puts all of the work of the impeller on the sides of the, or on the outside of the impeller, and it works both sides at the same time. So the fluid is introduced on one side, and as it goes through the pump, it gets worked over and over again. As it works its way around, it gets to the end here where it hits a water stop, and then it goes out at a much higher pressure than when it started, and it maintains a pretty low to moderate flow. So comparing that to a multi-stage centrifugal pump, here we've got a centrifugal pump that has between 3 and 25 stages to it, and we're comparing it to one of our T51 series pumps, which is just a single impeller. We have a couple different model sizes for that single impeller, but here you can see with just one impeller, we can pretty much cross over any point that's inside of the 23 stages or 25 stages of this pump, which means we could replace essentially a very large stacked centrifugal pump with just a single impellered pump, which is ideal for OEMs or limited space when you have maybe you want to put your pump in a cabinet where it's put into a quieter situation. Filler manufacturers like using them because of that. Another comparison would be to a rotary vane pump. Some people call them a sliding vane. Basically, you have a couple of blades that slide back and forth as the pump rotates, and that's how they get their pressure, is by forcing the fluid through without letting any fluid escape. There's a company, Fluidotech, or Procon, I think both of those, where the liquid goes in, it goes through this sliding vane, and then goes out. As a result, you get pulsation. You get the break in the fluid makes it have a waviness to the flow, and there's rubbing parts that move. So usually a regenerative turbine could last quite a bit longer under the right conditions, of course. And then with the regenerative turbine pump, normally a close coupled pump would run at a foot or less under normal circumstances of NPSH required. But some of our larger pumps, and it's typical to most regenerative turbine pumps, is when you have a larger pump, they usually need between 4 to 16 feet of NPSH required. If you have boiling water or anything that's hot liquid that it will vaporize, turn to steam when it gets too warm, usually most pumps can't pump steam, they can only pump the solid fluids. So if you get to a spot where you need a lower NPSH pump, we can put an inducer impeller in front of the regenerative turbine impeller. With the 100 series pumps, it makes it a 200. With the M series pumps, it makes it an L series. That it can take that NPSH required from 4 to 16 feet down to a constant 1 or 2 feet. So it can really drop that NPSH. We'll get into some of the applications here. We're going to start out with air heating and refrigeration applications and other construction type applications. So the first one here is booster service. Any kind of application that would require you to be able to move water up to a higher level, or use water for a higher pressure, like a pressure wash for a car or truck wash. You would use a regenerative turbine pump for that. With some of the water jets, the regenerative turbine pump cannot produce that much pressure. Usually it's 20,000 psi or more. But what a regenerative turbine pump does do is it is usually used as a priming pump for these cutting water jet type cutting tools. But yeah, any kind of pressure boosting up multiple floors, MTH pumps work very well for that. One of the other applications here is a boiler feed service. If you're not familiar, boiler feed is where you have a boiler system in a building and the boiler is under pressure and it needs to circulate that hot water or steam as it's operating. Well, when that steam turns back into water after it's been circulating, it evaporates and goes into a condensate collection system. And you need to refill the boiler. Well, when you refill the boiler, you have to have a high pressure pump in order to refill it. So regenerative turbine pumps work really well for that. They use this kind of system for multiple different kinds of buildings, but they also use them in different kinds of processes, including microbreweries and other brewing type applications where they need to heat things up or cool them down quickly. And then after that water has, or that steam has condensed back to water and is collected in a condensate system, you can either return it back to the boiler feed pump or the boiler feed set, which doesn't require a large amount of pressure. So we do have centrifugal pumps that work well for that. But if you want to move that condensate directly back into the boiler system, you can use a regenerative turbine pump. The display that is on the screen here is showing a turbine pump with a flange on it, that the flange is just a blank flange. We have programmed in our CNC machines the ability to take this blank flange and cut it to any existing flange size that's within these parameters. So if you have an Aurora or a Dunham Bush or a Shipto or a Sterling, we can usually fit it up to the existing tank, so you don't have to remount studs and do a lot of custom work to get it to fit. Another application is when you have a fire system, especially if it has multiple floors. City pressure only has a certain amount of pressure to it, so you need something to boost that pressure up to a higher amount so that you can maintain the pressure behind the sprinklers. The way a fire system would normally work is you would have two pumps. You'd have a large pump, the main pump for the fire system, and then you'd have a smaller pump that would only kick on every once in a while when it needs to repressurize the system. When there is a fire and the sprinkler gets set off, that sprinkler releases pressure, tells the system that hey, there's a fire, it releases the rest of the sprinklers and kicks on the big pump that dumps hundreds or thousands of gallons a minute. But you don't want pressure leaking from somewhere, whether it be from a check valve or a leaky pipe. So you want to make sure that that stays under pressure, and you use a regenerative turbine pump to be able to put that pressure at a much higher rate. If at any point anybody has any questions, please feel free to ask. We do have a question and answer box in this webinar here, so feel free if any questions come up. Otherwise, you can just email me or any of our regional guys if you have any questions that you'd like more information on. Feel free to email us afterwards. So continuing on, another application here is coolant systems. Any kind of geothermal heating and cooling, you need to be able to circulate fluids over great distances, usually down hundreds, if not thousands of feet through piping that all has friction losses, and then back up again. Regenerative turbine pumps work well for that because they can maintain the same amount of flow no matter what the pressure conditions are, or change it very little. So they work well for geothermal heating and cooling. Some of the other cooling systems are any kind of cutting tool that uses a high amount of heat, whether it's a plasma cutter or a laser or any kind of welder. You can use high pressure to push coolant or any other type of fluid through the cutting tip of the tool to be able to keep it cool. So when you're out looking for places to sell regenerative turbine pumps, any place that does any kind of cutting is going to have some type of system to be able to move fluids through the cutting tool. Which a lot of those systems use a chiller. And I had mentioned before that most of our pumps have a pretty small footprint that allows it to be able to fit into a smaller cabinet. They use these chillers for anything from welding machines all the way up to scientific equipment for manufacturing computer chips, solar panels, or even in medical imaging for MRI machines. They have to maintain that temperature while they're taking pictures while the MRI machine is in operation so that they can keep a clean, clear picture. Some of the other applications, which are pretty common high pressure applications, are any kind of closed loop systems where the whole entire system is under pressure. That would be heat recovery, hydronic systems, or the boiler feed, which we had just discussed. Other places that manage chemical processes, refineries, textile mills, or wood mills, all need high pressure fluids to be able to operate. So regenerative turbine pumps can usually be found in them as well. Any kind of fluid handling, fluid transfer, especially if you have to transfer from a low pressure to a high pressure, regenerative turbine pumps work well for that. They also work well with the mixing, especially for dissolved air flotation. One of the things I want to highlight here is this tank here is called a seal quench gland. And what it does is there's processes in the paper and pulp industry that use a fluid that will crystallize if exposed to the outside atmosphere. And so the way a seal works is you have your seal seat and then you have your rotating element, and a thin film of the fluid forms in between it to help it make a barrier that keeps it from going to the outside atmosphere. Well, with a fluid that will crystallize with outside atmosphere, that thin barrier of fluid will slowly eat away at the seal until you have a total seal failure. And in the paper and pulp industry, when that happens, it's a catastrophic failure that messes up the whole process. So by using this seal quench gland, we put a sight glass in here, and it puts a barrier between the seal on the inside of the pump and the outside atmosphere. And so there's oil in between here inside of this quench gland, and the oil circulates really slowly and it doesn't leak. So with the sight glass, what you can do is instead of worrying about a catastrophic failure in your system, you can just have your maintenance guy take a look at the the sight glass, and if the fluid in it, the oil in it, is higher than it should be, lower, or you can even see if it's cloudy or not, then you know it's time to change the seal, and you can schedule out for a proper maintenance rather than having that catastrophic failure. Another application is de-icing of airplanes. Any type of spraying with any fluid that needs to go out at a high pressure. Regenerative turbine pumps work very well for. Deionized water handling. Anytime you need a clean room type situation, we do have a version of our pumps that are sealless canned motor pumps. One of the things we're developing right now is we are working on a mag drive version of our pumps as well, but that's still a ways out. But any kind of deionized water, reverse osmosis, any processes like that that need clean fluids, MTH pumps are ideal for. Along with fuel cells, this is our can motor pump. So this is our X41 series. It gets used in a lot of different applications. One of them is when they do a fuel cell that they put on top of a building or on the corner of a city block for a hospital. If the power goes out, it uses a fuel cell to be able to operate and use a regenerative turbine pump to circulate coolant or whatever other processes need to be used for it. One of our newer pumps is our HP series pump. These are our welded, hermetically sealed pumps. They get used primarily for freons and CO2. This includes any other kind of refrigerant that is non-conductive because it's a wet wire pump. The fluid goes through the motor while it's operating, so you can't have any fluid circulating through it that is conductive, or it could cause electrical short. But these get used primarily in economizer packages. So the way that works is when you have a refrigeration unit in a building, you have a compressor that works with it. Usually that compressor is 10, 20, or even 30 horsepower. And when that compressor needs to run 24 hours a day, 7 days a week, well, when you use an economizer package and the weather outside is at or below the temperature you need to refrigerate at, you can turn off this very large compressor and circulate the freon using one of our smaller pumps in this economizer package, and it goes through a heat exchanger that's either on the roof or the side of the building that can use a significantly less amount of electricity. If you have a building where they have several refrigeration units running, you could have several of these compressors running all at one time using a lot of electricity to operate. If you can shut those down for a couple hours a night, or even during a whole entire winter season, using a 1 or up to 4 horsepower motor instead of a 20, 30, or 30 horsepower motor driving a compressor, you can save a lot of electricity that way. We'll look a little bit into the water and wastewater applications. One of the big ones for MTH here is the dissolved air flotation, or DAFF. They use DAFF in a couple of different areas. The way it works with the regenerative turbine pump is regenerative turbine pumps, commonly known for their high pressure, don't get used for high pressure in DAFF. Instead of getting used for high pressure, we take advantage of the number of impeller vanes that are in the pump, and we introduce air into the suction side of the pump, and that air will mix with the water and produce these microbubbles. These microbubbles go into a wastewater area, and they grab onto the particles that are in the water and pull them up to the top of the water, where they can be skimmed off, and they can either reuse the water somewhere else, or they can clean it enough to be able to put down the a normal drain that would go into a normal city wastewater facility. Where these get used at that we know of are in different kinds of food processing. When you have all the processes done for making food, you usually have quite a bit of water that has a lot of the bits and pieces of whatever process you are doing mixed in with it, and it's too dirty to be able to put down a normal drain. So normal circumstances, some companies just store it, and then they pay a lot of money to have it picked up after they've stored it for so long, and their tanks fill up. They have another company come out, pick it up, drive it to a rendering plant, and then break it down that way. But other companies, when they have a DAFF system, they can clean the water right there on the spot and either reuse it for other things or have it clean enough to be able to put down that drain. Other places that we've seen these used are in the oil and fracking industries, when they put that high pressure water into the ground to be able to push that oil up after they've collected all the oil. They have to reclaim all that water. Previous to using DAFF systems, they would just store that water as toxic waste. But instead of storing it as toxic waste, they can now use a DAFF system in it and clean that water up enough to be able to use at another site. It wouldn't be clean enough to put back into the environment, but it would be clean enough to use at another site. And I should mention, by having a regenerative turbine pump as a DAFF pump, you would actually replace any compressed air mixers or pressure vessels needed to use inside of your DAFF system. So you would actually replace a whole bunch of equipment that's usually pretty expensive just by using one of our MTH DAFF pumps. Some of the other applications here are seal flushing, filter backflush, extractors, or groundwater remediation. All these work on the same principle, that there is already fluid moving through something, either it's a filter or through a process, and you would use a high pressure DAFF pump to be able, or high pressure regenerative turbine pump to be able to push fluid through the opposite direction to be able to clean out either a filter or any kind of groundwater remediation trays or anything like that. Or if you have a very large pump with a very large seal in it that's expensive and causes a lot of maintenance when you have to change it out, you can use a regenerative turbine pump to push a higher volume of or a higher pressure of clean fluid into that mechanical seal area to be able to keep that seal clean and cool so that it can last longer. One of the questions we have here: what type of contamination level can you have on a DAFF pump? Size, viscosity, etc. Usually, DAFF pumps are the last step after water has already been filtered and strained and everything. So the particulate size is usually pretty small. When we run strainers on our pumps, we usually use a 20 mesh strainer. So pretty much anything smaller than that would be necessary. And in most DAFF situations, they are using them with water. So viscosity isn't really an issue with that, unless there's a lot of debris in it, in which case most filters should catch most of that first before you bring it to the DAFF. We have more information on that. If you want to find out more later, I can hook you up with one of our engineers. Moving on here, one of the other pumps that we do have is we do have a DC 12-volt pump. The one that's on here is our DC 10. It's actually a centrifugal pump, but the same motor that gets used for the DC 10 can also work with our T-Series and E-Series T31s and E41 and 51 pumps. So if you need a DC powered pump, we can do that using this motor. One of the other things I wanted to point out here was we have a customer that will order our pumps with a bearing pedestal. We can bearing pedestal mount any one of our pumps, and they were using this bearing pedestal with a coupling and using it for a hydraulic drive or a PTO, so that they could use it with some agricultural customers that they had. What they actually did with this specific one was they were pumping the DEF, the diesel exhaust fluid, with our pump, so that when they were refilling a tractor that was out in the field doing the plowing during the season, they'd bring out the big truck to refill it, and they'd also be able to use our smaller pump to be able to refuel the diesel exhaust fluid at the same time. Another application here is high pressure coolant. We have customers that use regenerative turbine pumps, sometimes up to the 1,000 psi pressure mark. They use them to blow coolant onto a cutting tool in a CNC machine at this really high pressure. And by using this high pressure, it makes it so that every cut is like the first cut. It can extend the life of the cutting tool, usually making the cutting tools last longer and make the parts more accurately. Another application here is hydrostatic testing. If you have any kind of facility that makes any kind of tank, valve, other types of pumps, or piping, you usually need to have a method to be able to test whether or not they can hold a certain amount of pressure. The easiest way to do that is by plugging all the holes and using a regenerative turbine pump to pump in a high amount or a high pressure of liquid. You turn off the pump, close the valve, and then you have time to be able to search the equipment to see if there's any leaks to prevent them from being found later when they're out in the field. A couple more applications here. And we're almost done. We have pressure injection. Anytime you see treated wood, the way they treat it is they put it into a pressure vessel, and then they pump creosote into that pressure vessel using the regenerative turbine pump. And that's how it is injected into the wood, is through that method. Other high pressure methods for pressure injection would be for curing agents into concrete when they have certain environmental conditions and the need to have the concrete have a certain amount of curing time. They would use regenerative turbine pump to pump in that curing agent to be able to properly have that cement set up. Other applications are with spraying. Anytime you need to have any kind of cleaning, just like the car washes or any other types of washes, you can use a regenerative turbine pump. They use them a lot for cleaning inside of food facilities where you just using that high pressure for using clean, um, flowing clean water onto different parts of the processes. Another application along the same line is shooting water through a fine nozzle that makes a fine mist with a large fan behind it. It puts out a mist over a construction site or demolition site. And what that does is it creates dust control. The mist will grab onto water particles and keep them closer to the ground so that you don't have as much dust as you would normally have in a dry situation. Other applications here, laboratory equipment. Anytime you need something that requires temperature regulation or any kind of high pressure fluids, regenerative turbine pumps, particularly our regenerative turbine pumps, work really well because you can oftentimes control the exact pressure and flow that you need with a regenerative turbine pump down to even a quarter of a gallon a minute. They're very scientifically engineered to be able to maintain a very steady, very stable flow. And then another application, it's actually very similar to the geothermal heating and cooling, is sampling. So when you have a very large facility with one centralized analyzing station, you can have a series of piping throughout that entire facility that can take samples of any type of fluid from different locations and move them over hundreds or even thousands of feet to one central location where it can be tested. So they work very well for sampling. And then some of the other aspects, at least of the MTH pumps, are that we have a number of materials. Our standard materials are bronze fitted, but we also have all iron, all bronze, and stainless steel. And we also have a number of elastomer options as well as a whole bunch of different seal options. And we do have some different accessories to make our pumps vertical. We can put steel flushes in. We do that quench gland, injection ports. We do have pressure relief valves and strainers here at the facility, so you can order your pump with those pieces on them. And we can passivate our stainless steel. So we do have a number of options for our pumps. Like I had mentioned earlier, we have a full sales staff here, which I do have this in an Excel format or PDF if you want a copy of it later. But we do have all of our salespeople available at normal business hours. So anytime you need to get a hold of a real person, you can. Some of the upcoming events, we are going to be doing our next MTH School of Pumps, I think in October. We're still planning on that right now. We've already successfully held about 4 or 5 of them. What we do is we invite our distribution from all over the world to be able to come to our facility for 2 days for some intense training. You get to work with our engineers. We get to go out to assembly and build pumps and see how they're tested, and get to do a full tour of our facility, get to go in the foundry, see metal being poured. And we do have a classroom set up so that you get to learn some very fine details of fluids and different technologies. Some of the other things that we're working on, like I had mentioned earlier, we are working on a sealless mag drive configuration that will be able to go between the motor and the pump to convert any one of our pumps into a mag drive pump. We have been working on for a while now, and we're still working on an ammonia transfer pump. For those of you unfamiliar, ammonia for refrigeration for the warehouses will boil at about 85 degrees, so it'll start to vaporize. So it's very hard to pump. So we're working on a super low NPSH version of a pump that is going to be made just for ammonia. And this is actually ongoing for almost a year now. We MTH installed over 600 solar panels on the roof of our building, and so we've gone as solar as we can go with this building. And I believe that even with 630 something solar panels, we still are only producing about 30% of the electricity needed to operate MTH. So MTH uses a lot of electricity. There's a lot of machinery going at all times. And that is just about it. Bob or Jim, did you guys want to add anything?
No, I think you've done a good job there, so not much I can add to that.
I agree, Scott.
Okay, well, if anybody has any questions, please feel free to email me when we're done or give me a call. I'm available usually Monday through Friday, 8 to 5, or you can just talk to any one of our salespeople or anything else. So,
Let me add something in it, Scott, if I could add something in
Sure.
for these fellows. You will find help available not only with Jim and I, but with the factory. And if you call into the factory, the number, it is automated, just hit the extension 2, and that turns you into the sales department where it will be picked up by a live person. If you hit the extension 2, it will rotate between every person up there until somebody picks it up. Usually it only takes a second, though somebody will grab the phone. So it's not like you're going to have to leave a message or whatever, like some places. You will talk with a live person when you call MTH.
Yep. I do also want to mention that we do have 2 full-time application engineers. So if you're having trouble with the selection, particularly if it's a non-water application, if you're doing something that's got some viscosity to it, or a different specific gravity, we do have a couple of application engineers that that's all they do all day long is select pumps for non-water applications. So that's available as well. So with that, I appreciate everybody taking the time out of your day to sit through this. We're going to be doing these webinars monthly, or we have been doing these webinars monthly. So I will send out emails for the next couple of them coming up. And thank you very much for your time, and look forward to hearing from you later.
Thanks, Scott.